Hello, are you able to listen my voice?
Yes.
Okay. I hope you can see the cursor which is moving, right? The pointer. Are you able to see?
No, we are not able to see the pointer. We are just able to see the slide.
Okay. Whatever I'm writing, you are not able to see then.
No, it's reflecting now. It's reflecting.
Oh, okay, fine. Okay. So we will wait 2 more minutes others to join. Then we will start the first tutorial for group theory methods in physics. Okay. Okay, so let us start. So I'm Aishwarya from University of Hyderabad. I am a PMR fellow. So we are going to start the first course of group theory of group theory methods in physics. Okay, so I hope you all are started attending the classes whatever ma'am taught in last week. Okay, so we will solve today the problems, and the mainly tutorial class will be solving problems. Like it might be earlier years assignment problems, or it might be some other extra problems in the same what we taught in ma'am last weeks. Okay. Before today, the first few problems, around 10 problems, we will solve the basics like uh, related to the hydrogen atom and its Brown state and one-dimensional harmonic oscillator and all. After that, we will go to the first week session, that is introduction to discrete group, subgroup, and generator, and conjugacy classes. Okay, so that's what like today we are going planning to do, and if you have any doubt you can ask to me in the like classroom, as well as you can if while studying or something, if you have any doubt you can message in the NPTEL forum. You can do the queries, then we'll answer for that. Okay, so now let us start with some basic problems first. So the first problem, see that for a hydrogen atom the potential energy V R1 R2 between an electron and a proton at positions R1 and R2 respectively is a function of. Okay, so these I told you already, first few problems are very basic, and the basic which prerequisites which you know is should know is learn linear algebra, quantum mechanics, and special theory of relativity. So this is just related to linear algebra and quantum mechanics. The first few week classes, like you should know the basics, and it's just like if you listen the ma'am class once, then you can easily answer all the questions. Okay, and it is very important that like whatever the questions we are discussing in the tutorial session and whatever the examples ma'am solving in the class, definitely such kind of problems only will come in your assignment as well as in your exams. Okay, so how to solve this problem? So let us take two axes and we are representing, like, this is origin. Okay, so first vector, this is r1, and we are considering the other vector, that is r2 vector. Okay, now this is correspond to electron, this is correspond to proton, that is the position vectors of electron and proton. Okay, so for a hydrogen atom, bound state of electron and proton, we can represent in the vector like this. Okay, so then what will be the relation between these two? It will be r1 vector minus r2 vector, right? We know the basics algebra. Then we know that the potential energy, which is V of r1 vector comma r2 vector, the potential depends on each positions. So what will the formula? We know, we already learned in plus 2 basics level, QE divided by charge QP, like charge of both electron and proton divided by 4 pi epsilon 0 r1 vector minus r2 vector. Right, so we know the charge of proton and electron same, so it will be minus E square. Okay, then 4 pi epsilon 0 r1 vector minus r2 vector. Okay, so the negative potential energy in this means indicate what? It is a attractive potential, which means Coulomb potential, nothing but it is Coulomb potential. Okay, so the so then the answer will be what? The answer will be the second one, r1 minus r2. So please go through it once, then we will move to the next problem. Okay. So I will explain it once again. For a hydrogen atom, the potential energy, which is V of R1 R2, which is depends on two position vectors of electron and as well as proton. Okay, so the position vector we can represent as R1 and R2, which is corresponding, R1 correspond to electron and R2 correspond to proton respectively. Okay, now the question is which is a function of what? So 4 options are given. R1 plus R2, R1 minus R2, R1 minus R2 like separate modulus, and magnitude of R1 plus magnitude of R2. Okay, so in this, what we have to do, this is very basic thing, we have to just know the charge and do that. Okay, nothing but it is like a Coulomb potential, because one is it will be, one is electron is negative charge, proton is positive charge, it will be Coulomb attractive force. So we have to know the potential formula, how we will handle with Coulomb forces. Okay, then the potential energy we can write it as QE1 QP divided by 4 pi epsilon 0 R1 minus R2, then it will be minus E square divided by 4 pi epsilon 0 R1 minus R2. Okay, then the negative sign here, which is indicating physically what, which is the potential, which is the attractive potential. So I hope you understood this problem. So let us move to the second problem. Okay. So for the ground, the second problem is for the ground state of one-dimensional quantum harmonic oscillator, the expectation value of the position operator x cap is non-zero or zero. That's what we have to do. So this problem we can solve two different ways. Okay, so the first method. Okay, so we are taking the function psi 0 of x, which is proportional to e raised to minus kx square. Considering a Gaussian function here, where k is some constant. Okay. Now, the expectation value of position operator. That we can take x cap. So its expectation value, what it will be? Expectation value of x will be psi 0 of x, psi 0 of x. Okay, so that we can write it as integral minus infinity to infinity dx psi 0 star of x in x, then psi 0 of x. Then that we can write it as integral minus infinity to infinity dx x psi 0 of x whole square. Right. So then that it will be, we know that our function, which is equal to e to the power minus kx square. So substitute that. So minus infinity to infinity dx x e to the power minus kx square. Now we know that x is a odd function, right? And this one will be an even function of x. Then if you take the integration, you will get the answer 0. So product of odd function like this is an odd function, this is an even function. The product of between odd and even function will be odd function. If you integrate odd function in between minus infinity to infinity, which is over a symmetrical interval, it is not minus infinity, it should be an in symmetrical interval, then your answer will be 0. Then we can tell that the expectation value of x will be 0. So the answer is 0. Okay, so this is one method. Please go through it, then we will go to the another one. Next problem. The operations under which only one of the vertices of an equilateral triangle is not moved. Okay, so options are rotation by 120 degree about the axis passing through the center and perpendicular to the plane of the triangle. The second option, rotation by 180 degree about the axis passing through one of its vertex and lying in a plane of the triangle. A rotation by 180 degree about the axis passing through its center and perpendicular to the plane of the triangle. Okay. Now let us try the each options how it will be. So we are considering a triangle. Okay, so A, B, C, and this is a center O. Okay, now first one is we are rotating r of theta, that will be 120 degree about O, which is in a perpendicular plane. Okay. Then what will happen? A, B, C. It will be like this, right? Then we can move that A, B, C, which is moved. Okay. Now next one with it 180 degree. Okay, so we are considering A, B, C, the angle O. Now we are rotating 180 degree. Okay, about O, which is perpendicular to the plane. Now if we rotate 180 degree, what will happen? It will come to the same position, ABC. Okay, so we can move that ABC, which is moved. Now the third one, considering ABC. Okay, O. Now the third one is, okay, this is like passing through A in the plane, passing one of the vertex. So we are considering passing through A just like this. Then we are rotating. So what will happen? If we are considering this as a base, and if you rotate 180 degree, passing through A in the plane, what will happen? It is A will be there, but B and C will be rotated, right? If you are rotating 180 degree, it will go here. So it will be like B, C, this is O. Then what will happen? A, which is not moved, B, C moved. So the answer will be rotation by 180 degree about the axis, passing through the vertex A, lying in the plane of the triangle. Okay. So just go through it, then we'll move to the next one.
Ma'am,
Yeah.
could you explain the second one, 180 degree?
Okay, second one, yes. if you rotate like the angle which is perpendicular to this axis, and if you rotate it 180 degree, okay, like how you rotate 120 degree here, then the B will come here, which is this angle is 120 degree. And what will happen here? Thus we are checking it will be movable or not. So if you rotate 180 degree, the picture actually look like inverted triangle like this. Okay, then A, B, C, it will come here. Before A was here, if you rotate 180 degree, it will come here. Okay, the triangle will be look like this. We are focusing which is to be movable or not. So that's why I have written ABC, which is moving.
Okay, ma'am.
Yeah.
That's fine.
Now let us move to the next problem. The energy eigenfunctions of psi n of x of a one-dimensional harmonic oscillator are either even or odd function of s. So first let us discuss the one-dimensional harmonic oscillator, the potential energy, and the Schrodinger equation. Okay, so the potential energy function V of x for one-dimensional harmonic oscillator is an even function. How it will be an even function? What will be the formula of a potential of harmonic oscillator? It is half m omega square x square. So it's depending on x square, right? So it is an even function. So v of x, we can write it as v of minus x. Okay, now this potential used to be if we are using to find the eigenfunction through the Schrodinger time dependent equation. So Schrodinger time dependent equation, then we can write it as minus h hat square divided by 2m del square plus v of x into psi of x is equal to e psi of x. Okay, so under parity transformation, which means Under parity transformation, nothing but it is a spatial inversion. Okay, what we can write? X changes to minus x. Then our Schrodinger time dependent equation becomes minus h cross square divided by 2m del square plus v of x into psi of minus x, that is equal to e psi of minus x. Okay, which is like here also we have to give the minus x, but we know that v of minus x is equal to v of x, so I have given that it is a v of x. Okay, now we have to see that both functions psi of x and psi of minus x solve the Schrodinger equation, and so does the it will be like a linear combinations. So when we can construct two possible ways of solutions, that is psi even of x, that we can write it as psi of x plus psi of minus x. Okay, then similarly psi odd function of x, that will be psi of x minus psi of minus x. So then the answer will be true. So the energy functions of psi n of x of a one-dimensional harmonic oscillator are either even function or odd function. So what we have to do here normally, we have to solve the Schrodinger equation, that is psi value, how it will be for a harmonic oscillator. So for the first we need to know about the potential energy and kinetic energy part. So that is nothing but Schrodinger equation, right? So potential energy, we know that it is a half m omega square x square, and we are do the inversion operation, so that minus x, if you substitute, that will be nothing but v of x, because x square term is there, so it is even. Now we are applying this condition to the Schrodinger equation. Schrodinger equation, you can see that kinetic energy, which is representing by minus h square by 2m del square, and the potential energy part, and we are multiplying with the wave function, we will get the eigenvalue E and psi of x. So under parity transformation, we are substituting this x changes to minus x. We are substituting the minus x in the Schrodinger time dependent equation. Then all the place of x, whatever you are seeing, it will become minus x. So then you can get the two solutions. One is psi of minus x, like that is solving like two equations we are getting. One is the first one, this one, and another is the second one, this. So here we don't know the, like it is minus x, we don't know the wave function here now. So we, while constructing the wave function and solving it, you will get the value of psi as a 2. One is psi even function, that is psi of x plus psi of minus x. Similarly odd function psi of x minus psi of minus x. Okay, so that will be the solution for this question. Okay, let us move to the next problem. It is very simple problem. A triatomic molecule will have 8 degrees of freedom. Okay, so a triatomic molecule will have in general how many degrees of freedom? So triatomic molecule means 3 atoms. Okay, 3 atoms will have in general 3n degrees of freedom, that is 3 into 3, that is equal to 9. In that 9 degrees of freedom, it will be 3 translational, 3 rotational, 3 vibrational. Okay, so this is wrong, false. It is very easy. Now let us move to the next problem. The first excited state of hydrogen atom is degenerated or non-degenerated. So to answer this, first we should know about the hydrogen atom problem, right? So the energy state of hydrogen atom is specifically we can represent 3 quantum numbers. What are they? Like we can represent the wave functions I, N, L, M, L, NL, ML and R vector. So N will be the principal quantum number and L will be the orbital angular momentum quantum number and ML will be the azimuthal quantum number. Azimuthal quantum number or magnetic quantum number, whatever it is. Okay, so for a given N, L range from the okay, for a given N, the L range from the 0 to n minus 1. Okay, for n values. For given L, M ranges minus L to plus L, right? So there will be 2L plus 1 values. Okay, now N we can take it as which values? 1, 2, 3, 3, etc. values we can take for N. Now energy eigenvalues of hydrogen atom, we know that energy which is proportional to 1 by n square, which is only depending on then this n, which is only depending on the r, the position vector. But the different combination of L and ML can correspond to same n values. Okay, so hence the degeneracy of eigenstate is a particular n value. If you are considering a particular n value, the degeneracy will be L from 0 to n minus 1. The degeneracy in ML, we can write it as summation over L equals 0 to n minus 1 2L plus 1, that is nothing but n square. So the degeneracy of the first excited set. Now if we say first excited state, okay, so first excited means what? N equal to 2 and hydrogen atom is 2 square, that will be 4. So the d4, it is a 4, it's a degenerated with the degeneracy number 4. So what will be the psi values then? That will be 1 0 0, psi will be 1 1 minus 1, then psi 1 1 0 and psi 1 1 1. So these 4 state can be possible. N M L means N L M values. Okay, this is possible for the first excited state of the hydrogen atom. So it is a degenerated state. Okay. Now let us move to the next problem. The matrix denoting inversion of the spatial coordinate x, y, z have determinant. Okay, so now ma'am told that we can represent the matrix like rotation or inversion, whatever the symmetric operation, in matrix form also, right? So the metric representation denoting inversion of a spatial coordinate have determinant. So first we have to know what is the inversion matrix. Okay, so inversion corresponds to the transformation of the coordinate, like x changes to x dash, that is nothing but minus x. Okay, y changes to y dash, that is nothing but minus y, and z changes to z dash, that is minus z. Okay, this is in three-dimensional 3D space we are discussing. Okay, now the transformation matrix, we can write it as x dash, y dash, z dash. It is a column matrix. The transformation minus 1 0 0 0 minus 1 0 0 0 minus 1 into x y z. If you multiply it, you will get minus x minus y minus z. So here this is the inversion matrix. Okay, in 3D, and the determinant of this matrix minus 1 0 0 0 minus 1 0 0 0 minus 1, it will be minus 1 whole cube, that is minus 1. So the answer will be minus 1.
Ma'am, why is it called a non-trivial subgroup? Hello, ma'am. Ma'am,
Hello, can you hear me?
Ma'am, yeah, I can hear you.
Okay. I hope the mic had some problem. You might not hear the earlier ones, right?
No, ma'am, there was some problem. I have a doubt regarding the last question.
Okay, you can ask.
So, you did mention that the three groups were non-trivial groups,
Mm.
the H2, H3, H4.
Yes.
So,
No,
why are they
H5
called?
also. H5 also.
Okay, it's okay. Okay, fine. It's five also. Why are they called non-trivial?
No, actually, trivial and non-trivial group is a classification of group. The trivial group which include the identity element. Okay.
Oh, okay,
And the
okay.
identity element and as well as the same group elements. Complete the as the group it is. Remaining all are
Oh,
non-trivial.
okay. I mean, except identity and the group itself, others are
Yes. All
non-trivial.
are non-trivial. Like
Okay.
metrics we are saying, right? Similar way.
Oh, okay. Okay. Fine. Thank you, ma'am.
Yeah. Now let us go to the seventh problem of the first week assignment, means related to first week. So the question is, the union of all the cosets of a particular group forms the group itself. So what it is, like union of all cosets of G3. For example, we are taking G3. Okay. Now the left and right cosets for H3 subgroup. That is, we know that we discussed now just before the question. EB B square are like EH3. Oh, can you mute it? Let me say this to you.
Okay.
E B B square, right? The same group will get it, and A into H3, that will be what? AB square. So only two cosets for the subgroup H3. Okay, so all the element of group G3 we can are taken into account by the cosets of this first one and the second one. This is first one and the second one of the subgroup of H3. So hence their union. So EH3 union AH3, you can write it, you will get the complete G3. That is E B B square AB AB square. Okay, so that is G of 3. So that answer will be which is true. This is ma'am solved already in the classroom. Just we have written again. That's it. Now let us move to the next one. The possible order of the subgroup for a group of order 5 can be. Okay. So we know that Lagrange theorem, that is for any finite group G, the order of every subgroup H of G divides the order of G, right? So we know that order of G divided by order of H, it will be integer. That is the Lagrangian theorem saying. So if you see the options, so 5 is divisible by 5, then only we will get integer or either 1. So the options can be 1 or 5. That's it. It's just application of Lagrange theorem to solve this. Okay. Now let us move to the another one. For a symmetric group G3, we know the elements. The factor group is. So what are the factors group for G3? So the invariant subgroup, this, we know that H3 is a invariant subgroup, right? For a symmetric group we know the conditions already. A square is equal to B cube, that is equal to E, and BA we can write it as AB square, right? So when the invariant subgroup is E, B, B square. Okay. Now the factor group F for a group G defined as what? G divided by H invariant, where H invariant is a subgroup of H invariant should be the subgroup of G. Now for the factor group, we can represent it as F is equal to G of 3 divided by H3, that will be E comma A. Okay. So now how we can show that? The first one is H3E is equal to EH3. So it will be like same as like E B B square. Okay. If you take union with that, the other element H3A, that is equal to AH3, we know that because it is invariant. So it will be A, AB, AB square. If you take the union, then what will happen? It is the complete G3. So then here it is E comma A, this element group is the factor group here. So the answer will be the third one. Now let us go to the last problem for today's session. The group G that is equal to R plus with the group operations as multiplication is isomorphic to the group H, that set of all real numbers, okay, with the group of operation as addition. So first let us see. So what are the things are given? So G that is R plus, which means group operation with multiplication G star, okay, and H subgroup that is R with a group operation with H plus. Okay, now we are mapping G star with H star, so H plus. Okay, so this is domain, this is range. Okay, he say homomorphism if for all a comma b which is belongs to G that there exists a phi of a, phi of b belongs to H, such that we can write it as phi of a star b, that will be phi of a plus phi of b. Okay, now a homomorphism that is both 1 to 1 and onto, that we know that, right? And onto is a isomorphism. So a homomorphism that both 1 to 1 and both together, and isomorphism because surjective things. So then if we representing it as like a comma b, we are considering a group G, okay, and the H we are calling it as 1 2 3, and if a mapping with the b mapping with 3, okay, so 5 we are calling this, then this will be injective, all elements of a which is mapped with the all elements of G which is mapped with the H. Now plus the other group we are calling it as G A B C, okay, and 1 2, if you are mapping everything like a mapping with 1 and this is 2, this is we know that surjective, this is isomorphism. Okay, now what we can say that a logarithmic mapping can exist between the group. So there will be a logarithmic mapping which can exist with the group that G star and H plus. So that is log a star b, that is equal to log a plus log b for all a comma b which is belongs to G, that is R plus, and log a comma log b belongs to H, real numbers. So then if you plot it like it's a logarithmic function, so it will be like this, it is crossing here at 1, okay, phi of x is equal to log x. So the answer is true. Okay, so this much, these are the problems. So which we discussed today. So please go through the problems whatever we discussed in the tutorial session. It will be helpful for you to solve the assignments. Okay, so see you in the next tutorial session in the next Tuesday. Okay, thank you.
Thank you, ma'am.